So we're working on translating epigenetic rejuvenation approach. We're trying to create a gene therapy for epigenetic rejuvenation that will enable people to, at regular intervals, become younger, essentially. And so this will not only make them healthier, but also greatly extend their lifespan. My name is Yuri Deigin. I'm a CEO and founder of Youthereum Genetics, and I'm also the vice president of Science for Life Extension Foundation. It's a Russian nonprofit foundation dedicated to spreading the word about life extension. What brings me to the conference? Well, this is the place to be. This is the conference for probably premier conference for life extension every year that Albury now hosts. Every year, it used to be every other year, but now it's every year, so can't miss it. Have to be in Berlin. So what brings me here? Hearing other people talk about the things that they've accomplished in the year, new research results, and also I'm presenting on investigation on Jean Calment later today, so those things bring me here. Sure, so it's a company dedicated to translating the epigenetic rejuvenation approach. So basically taking the results in the lab that we see potential rejuvenation of animals and turning it into a gene therapy that can eventually be applied to humans. So we are a very early startup at this stage, but hopefully, maybe not just us, but other startups will bring this method to the clinic, the epigenetic rejuvenation method to the clinic. All organisms have genes, and each cell in our body has the same DNA, but we have very different cells. Like a skin cell is very different from a neuron or from a liver cell, and what makes those cells different are the different genes that are turned on in each type of cell. So the mechanisms that are responsible for which genes are on and which genes are off in a given type of cell, generally they're called epigenetic mechanisms. There are several different mechanisms, but they're all like one term that they use, epigenetics. So what also happens is during the development of the organism, different stages in life, even in the same types of cells, the pattern of gene expression changes, and we can differentiate an old cell from a young cell, even with the same cell type, by their epigenetic patterns. And we can also do that with the actual organisms themselves. Like you can take a skin cell from a person and know how old that person is, just based on their epigenetic signature. And what was noticed in the research is that we can actually rewind back the epigenetic clock, basically turn the pattern of gene expression in an entire organism to a more youthful state. And this is just very fresh research. It was done in 2016. The paper was published out of Salk Institute in California under the group of Juan Carlos Espiso-Belmonte. And they showed that for mice who were subjected to this gene therapy, their life was extended by up to 50%. Now, it was short-lived mice, and we're still waiting for results in regular-aged mice, but still, these are very optimistic preliminary results that, for us at least, they inspired us to accelerate the path to translation of this therapy. Because I think the biggest challenge in the whole life extension industry is that there still isn't anything applicable to humans that can greatly extend our lives. We talk about it a lot, but there's nothing right now that you and I can use to extend our lives by, say, 20 years, 30 years, nothing like, the mice have that can extend their lifespan by 50%. When those results go to primates, usually the life extension is much smaller, the percentage base. And we feel that it's a problem, and it's just not adequately realized. People don't have the sense of urgency that if we don't develop such therapies, then we're probably not going to live long enough to see any meaningful life extension developed in our lifetimes, or even in the lifetimes of our parents. And I think it's a problem. We need to accelerate the search for really radical life extension therapies. And this is the reason why we founded Youthereum 2 years ago, and I think this is the reason why we continue with activism, trying to educate not just regular people, but also the researchers, not educate the researchers, but inspire the researchers to have a little more sense of urgency, not just come to the conference to present the results and publish and wait 2 years to do something new, but to feel that they're developing a very important, essentially life-saving therapy. It's a life and death issue, and I think it should be treated as such by researchers, aging researchers, because they are the only people who can provide humanity with a cure for aging, or at least with a therapy that can greatly extend lifespan. And sometimes I just don't see enough urgency in the research, which is, in general, academic people are kind of laid back. They don't hurry up too much. They can get the results, publish a paper, do a round of media and presentations and conferences, and they can kind of milk the results for a year, and then they can publish subsequent results, like maybe tweak a little more research or get in depth into some issues, and they can get a new paper, and the whole carousel goes again. But I think with this approach, they're going to be successful dead researchers. But I think it's much more important to develop a therapy that will help humanity and themselves extend lifespan, and then they can spend whatever time they need on their research or any other pursuits. Yeah, we have a preliminary research plan that was, of course, contingent on the funding. If our idea was to get a lot of funding to parallelize this plan, to again speed up as much as possible the translation of this paradigm, the epigenetic rejuvenation paradigm. Basically, the timeline that we saw to get to clinical trials in humans was, I think, up to 8 years, and then clinical trials themselves take also up to between 8 to 10 years. And if we're lucky and if we parallelize a lot of things and get some successful results early, then we can see this therapy being clinically approved within maybe 10 years or 10 to 15 years. But if we're unlucky, it's probably 20 years. And again, it's not just us, there are several other companies developing it, and maybe with collaborations or some people using the results of another group, this can speed up this translation process even further. You mean the pets? Yes, of course. I think it's a very easy to understand issue. I think it's pretty self-explanatory that if you have a therapy that works not just for humans but for all mammals, to get it to the market as quickly as possible and to start generating revenue, companion animals, pets, or maybe even some racehorses, other animals, are a good first step because there are lower regulatory barriers, and you can get to the market quickly and start generating revenue, and also learn from that animal data that you can maybe apply that knowledge later to clinical trials in humans. So in our get to market plan, animals were the first step, and probably the cosmetics application was the second logical step, again because regulatory barriers could be much lower, and also the people's understanding of rejuvenation when they just top of their mind is cosmetic applications, skincare and stuff like that. So I think this just two first avenues of revenue generation just come trivially when you start thinking about the market entry strategy. Well, I think there are many reasons. First of all, there's learned helplessness that people have towards aging and death. We're born we're not born, but as soon as we're born, our parents and the society in general starts telling us that everybody dies, it's normal, everybody ages, and so we accept it as something that we shouldn't even try to change, right? Everybody used to die, everybody used to get old, so just accept your eventual decline and death, and enjoy the remainder of your life. And so that's one reason. Another reason, of course, it's psychologically very tough to come to grips with our mortality. There's whole schools of thought in psychology and psychiatry based on the dealing with fear of death. So it's a very uncomfortable topic that people, at a very early age, try to make peace with it and put it away out of their mind and continue living as if they will never die. They just don't think about it, right? And maybe they come up with various explanations why they will continue on living, maybe after death in mystical or religious paradigms. But so they don't really want to question their mortality on a daily basis. And so when you come to them with this question, it immediately makes them think of their mortality, because you're asking them, well, do you want to live longer? Which implies, do you want to not die soon enough? And for them, maybe it's uncomfortable to start questioning what they've already accepted in their psychology as what their views on their own mortality are. But I think as soon as there's something available on the market that will extend the lifespan, those people who are right now saying, oh, I don't know, they'll be, I'm sure, the first in line. Everybody, once there is a therapy to not just extend lifespan, but rejuvenate yourself, people won't think about it that they're using it to live longer. They'll be thinking about it, they're using it to be younger and healthier and better looking. And I'm sure everybody will use it as soon as it will be available and affordable. Well, usually, it's actually, I think, a very boring society, but the same as right now. Unlike what people usually want to see in, science fiction films. They want to see some conflict. They want to see something, like bad happen, because otherwise it's just a boring show like, the movie Her, about this future society where, everything is just about the same, but, you're probably going to be looking like you do at this age for much longer, hopefully. And doing the things that you do right now, you'll be just doing them for longer, as long as you enjoy them. And other things that will happen in society at large, like technological progress, they'll just in parallel happen with you kind of maintaining the health that you already do. There probably would be some, differences in relationships, like maybe people will be divorcing more if you live for hundreds of years longer, but those changes will not come for a very long time. It will take hundreds of years until these changes in society permeate the whole world, because this won't happen like this. Once the therapy is available, which still will take probably decades, the changes in society that it will bring, again, will take many decades, because aging is a gradual process, and the rejuvenation will mean that you won't abruptly, like 85-year-olds won't turn into 25-year-olds. No, they're probably just, hopefully, will be rejuvenated somewhat, but mostly people will just be able to delay their aging. So I don't think there'll be massive changes for maybe centuries to come. And by the time centuries pass, I think there would have been massive changes in general, even if we didn't cure aging, just because of technological and other things changing. So I think the impact of people living longer, or maybe even indefinitely, won't be felt or won't be that great that it would have been otherwise from other changes in society and technology. Altered carbon scenario, right? The rich immortals living in the clouds and the sheeple living in the slums. No, I don't think it will be like that, because every technology, when it just comes out, first it costs a lot and is available only to select few, but then very quickly, economics just drives the process of trying to make it mass produced, and then this makes it in turn cheaper. And with biotechnology, it's even more so, because once you actually know what kind of molecule you need to synthesize and what genes you need to put in a gene delivery vehicle, to reproduce it costs very little. And the drug prices are not high because it costs a lot to manufacture. The drug prices are high because there are patents that enable the people who created the drugs, who spent billions of dollars on getting them to market and passing them to clinical trials, to make back the money and some profit on what they spent on delivering this product. So yes, initially, while the patents are in force, the therapies will probably cost a lot, but as soon as the patents are over, and patents are only lasting 20 years, and usually by the time something gets to market, the remainder of the patent life is only maybe 5 or 6 years. So very quickly, like within a span of generation, or even within a span of 10 years, these therapies will become widely available at reasonable prices to anybody. More so because this is, I think, a universal right. This will become a humanitarian issue, that this therapy must be available to everybody. And there will be widespread political pressure, not just in developed world, but all over. Like I'm sure United Nations will take it up to make sure that everybody in the whole world is able to use these therapies at nominal cost. So no, I don't think there'll be this stratification between the immortal rich and the mortal poor. I think it's just the stuff of science fiction that is not economically viable. Yes, everybody hears of overpopulation who is at least starts looking into aging research. This is the first knee-jerk reaction of anybody who hears about the prospect of living longer. People recoil, I think, because of psychological issue, but their brain, gives them this nice excuse why they shouldn't start thinking about it, because they want to portray themselves as altruistic and saying, no, we shouldn't extend life because this will cause overpopulation and the whole planet will suffer. But I think this is, well, first of all, there's no economical underpinning behind this fear, the fear of overpopulation. Because since the times of Malthus, or even before that, people were afraid that, oh my God, we're going to run out of resources, food, water, oil, and making dire predictions that, in 20 years, in 100 years, this is going to happen and the world will reach a catastrophe. It never materializes just because the speed of technological progress is orders of magnitudes higher than the speed of population increase. Basically, at this point, this planet has 7.5 billion people whose average standard of living is much higher than at any time in history. And moreover, the standard of living of the average Earthling is probably higher than the standard of living of elites 200 years ago. We have access to food, water, clothing that people, even the elites, didn't have, or 24/7 fruits, vegetables, technology that is unfathomable, entertainment in the palm of the hand, everything, medicine. So I think all those fears that, oh my God, if we just stop dying, the planet is going to collapse, are completely unfounded. Also, more so because even if we stop dying tomorrow, nobody dies anymore, the time it takes for the planet to reach any significant level of people is going to take 50 years, 100 years. And the speed of technological progress, as I said, it's immense, it's crazy, and it's only accelerating. And the things that we're able to do in 50 or 100 years with agriculture or any other resource that at this point we kind of look at, say, oh, it's probably running out, I think it's completely unfounded. We're going to have energy from solar or wind. We're going to have agriculture that is using the earth resources or vertical farming much more efficiently, and any other thing that you can potentially think we're going to run out of, I think is completely unfounded. Well, I think just like anybody else, you first hear about it, you are skeptical, you say, oh my God, there's going to be overpopulation, so we shouldn't do it. And then you think about it rationally and logically, and you just understand that this makes sense. Dying does not make sense. Dying is bad, and trying to do anything or everything in our power to avoid it makes sense. I mean, we do it already with medicine, but for some reason we have different attitude when it's dying of old age. Somehow, dying of old age is okay. Grandma is dying, that's fine. Oh, but you had an accident, we're gonna call 911 and get to the emergency room and have, dozens of people try to save your life. I think this dichotomy is completely irrational, and when you think about it logically, it makes sense to also try to prevent grandma from dying. And unfortunately, we haven't, as a humanity, spent enough resources on this problem because we don't perceive it as a problem. On a general level, 95% of people in the world don't perceive it as a problem, probably because they don't think it's possible to do anything about biological aging. And this is the first problem. You actually have to realize that no, we can do something already. We have the biotechnology to at least understand what's causing this, and then to actually do something about it. So yeah, this is how I came to this movement. Just I was working in the biotech field, and some of my friends were working in biotech and both in life extension, and this drew me into first as an activist, as someone who just popularized the idea of aging, of fighting aging, and then using my kind of competencies in the drug development business, I got more into the research side of things, in the commercialization side of things, and became more involved already in the actual industry of producing therapies that potentially can lead to life extension. Well, this is probably the biggest misconception people have about evolution, that it somehow benefits us. Evolution does not benefit us, it benefits genes. And our interests and the interests of genes that created us are very different. We are not our genes. We are just replicators for our genes. And we've been kind of the slaves of the genes for millions or billions of years, but finally we have the potential and the capacity and the knowledge to overturn this yoke and actually use the genes to our advantage. And I don't care for evolution. We don't need to care how well the genes do. What we need to care, if we care about the humanity, we can change the genes in the direction that we think we should be going. We don't need sporadic mutations to arise, and which most of them are actually bad for you, right? Most mutations cause, or at least a lot of mutations cause bad things. Fetuses don't develop properly. You get people with genetic diseases. That part of evolution we don't need. Actually, we don't need evolution. We can do our own genetic changes that we think, as a humanity, as a society, are good in the future for future generations. So it's good that we're finally not slaves to blind genetic mutations that cause bad things and cause people to born with genetic diseases. And we as personalities, we shouldn't even be tied to our biology. Eventually, I'm sure we will leave these meat machines for some better substrates for our personality, something more durable, something that, if you get hit by a truck, your personality should persist. And we'll find new ways to exist, for our personalities to exist and to interact, that don't involve, biological substrates. I think it will come, sooner than later. Right now it sounds like science fiction, like altered carbon, but I think eventually this is the direction that humanity will go. Because we need to understand that just because our consciousness was initiated in this form, in this brain, it cannot be transformed to a different substrate. And so our biology is just an instrument for our personality to first arise. And then this instrument wasn't actually created for our benefit. It was created for the benefit of genes. It's just a happy coincidence that we've developed personalities, brains, intelligence high enough for us to actually, understand ourselves, understand our biology, and to actually start kind of caring for ourselves rather than having to, be led to the slaughter by the genes that create us and then dispose of us as soon as we've done our work of reproducing. So I think I gave you a very long and winded answer to a simpler question, but well, again, humans decide for themselves as humanity what is acceptable, what is ethical, and what is not, and this changes very much through the years. 2,000 years ago it was ethical to have genocide, to kill people and do very bad things that were in religious texts. Said, no, it's okay to kill your enemy, it's okay to annihilate the Amalekites. But right now we look at it and say, okay, well, maybe the religious text meant something different. No, it didn't mean something different. It's just 2,000 years ago it was okay. And now, as humans, as society, we say, no, this is not okay. This is not ethical. So, maybe 2,000 years ago they would have burned us at the stake and said, no, thou shalt not genetically modify humans. But now, I'm sure it's okay. Initially, people said test tube babies, IVF, in vitro fertilization is not okay, but now millions of people using it and are very happy about it. So we as a society, and different societies have different norms, in Saudi Arabia probably it's still going to be a while until they're okay with genetic modifications, but in Europe, in more advanced, ethically advanced countries from a scientific standpoint, Iceland, I'm sure very soon it will be okay to have genetically modified humans, genetically modified babies. And then other countries will follow suit as soon as it becomes safe to do so. Right now, the biggest issue with genetically modified humans is not the ethical issue. I think it's the safety issue. People think this therapy, this approach of genetic modification of embryos is still in very early stages, and we don't know the long-term effects. I mean, what rights do we have to impose on the unborn children the potential downsides that this therapy can still have? But as soon as we iron those things out and know that, no, for sure it's safe, the only genetic modifications that the new babies will inherit will be positive ones, then I'm sure this approach will be widely available and considered ethical. So I don't see any long-term issues with ethics. I'm sure this is the direction that humanity is going with, enjoying what science and technology affords us, the tools it enables us to use. We're happy to take it. Nobody's saying, again, religious people are saying we shouldn't accept blood transfusion because it's not in my religious text, or it's not approved of by my God. And most people look at it and at such person and say, you're crazy. And I'm sure, with time, more and more people will be okay with genetic modifications, even if they're not okay right now. It just takes time. Well, it depends what we consider as gods. We will develop into beings that are having much more power over their destiny than previous generations. That's a good thing. 1,000 years ago, I would have been born a slave and probably died at 25 or in combat. It's great that I don't have to do this right now and have the freedom to do what I actually want to do. And maybe to a Stone Age person looking at us right now, we'd kind of be gods, and if we fly in a plane and landed somewhere, we'd be treated as gods even, 200 years ago. But the definition of God in a regular context, I think it's kind of meaningless. Everybody, can decide what they want to do with their destiny, and whether that's not like superficial powers. There's just regular power afforded to us by science, technology, and medicine that we will have that are larger than generations past. But I mean, it's still not omnipotence, or it's not godlike just yet. And again, it's not a bad thing. Yeah, I mean, people have been desiring to be immortal and all-powerful since the beginning of time. They just fantasize about it and make these fantasies live out in the next life, in the afterlife, in the mystical realm. But of course, we know that this is our innate desire. We want those things. That's why we fantasize about them. That's why we put them in religious texts. And if we can implement at least some of these things in reality, that's great. People wanted to fly from the time of Icarus. Well, we can fly now. Are we gods? I mean, we're getting much more godlike powers that people only afforded to gods, but now regular people can have them. And hopefully immortality, or at least in a very long lifespan, will be one day one such thing. So, and it'd be great. I don't see any bad side of this. As long as possible, as long as I'm enjoying it and I'm healthy, I don't see any reason why I should stop. So this is the question. Because people think in the current paradigm that we have to die. So if we subscribe to this theory, then the question, how much do you want to live, makes sense. I have a specific time limit. I can only extend it to 120. I want to live 120. But if you think about it again from a rational standpoint, why would you want to die? And I mean, you could, maybe it's boring, or you just philosophically realize the emptiness of existence and you want out. That's fine, So you or I would want to live up until that point. But until then, I don't want to be forced into death or sickness by any other, external or genetically predetermined conditions. I just want to try to use the powers afforded to us by science to live as healthy and as long as possible. So I'm not sure if that's an answer you were looking for, but to most people it sounds like, oh, you want to live forever, right? Okay, if that's your definition of forever, yeah, I want to live for as long as I can, for as long as I'm enjoying it. So if that's forever, then be it. I want to live forever. I know, it's so cool. I want to visit Mars. I want to see, first interstellar travel, things like, I don't know, Dyson Sphere, can we build it within, 10,000 years? That'd be very interesting to see. And the things that are coming that we can't even imagine at this point, I think are even more interesting. And again, if you don't, if at some point you say, enough of this, you have the option. Right now we don't have the option. And I think it's all about humanity's progress is all about giving us more power and more options, which we don't have to use if we don't want to, but it's better than not having options and being forced to die at a particular age. So, well, of a cell, it's easy. That's what Yamanaka factors do. Shinya Yamanaka, he got a Nobel Prize in 2012 for the work of discovering the Yamanaka factors, the 4 transcription factors, that can turn any cell, any old skin cell, back into essentially an embryonic stem cell, a pluripotent cell that can then be differentiated back into a skin cell, but it will be a young skin cell that doesn't have the accumulated damage of an old skin cell. And there's been research that showed you take a 100-year-old fibroblast, a skin cell, transform it back to the induced pluripotent state, then transform it back into fibroblast, and all age-related hallmarks are basically gone. You have good mitochondria, no misfolded proteins, elongated telomeres, and basically the skin is now a young cell again. And so this process is basically you reset the epigenetic clock back to 0, because this happens during the reprogramming stage. All the epigenetic marks or epigenetic pattern is brought back to the embryonic state. And so this, luckily for us, this happens gradually. This is a gradual process that happens slowly. You reduce the epigenetic age, but you still can maintain the differentiation state of the cell. So the epigenetic process, the reprogramming process, while it happens, is luckily gradual. So when it starts, the epigenetic age decreases gradually, but the differentiation of the cell is also lost gradually. So there is a therapeutic window where the cell is still epigenetically younger, but it hasn't lost its differentiation. It's still a skin cell, which is important if we want to do this in vivo, in a live organism, because we don't want the cells to become suddenly something different than the type of cell that they are. And so what the approach, the epigenetic partial reprogramming approach, it's partial reprogramming. Basically, we don't want full reprogramming to the embryonic state, pluripotent state. We just want it to rewind back slightly to a more youthful epigenetic state, and then maybe do this on an ongoing basis, like once a month or once a year. I don't know. This is the dosing regimen that still has to be developed or discovered first. Mm-hmm. So, from like a bird's eye view, this is how this works. Our body, our cells, they kind of maintain this epigenetic clock. Every cell has this epigenetic pattern that, as I mentioned before, correlates with all other people of the same age. That's why you can have the clock. It doesn't matter whose cell you take, it matters how old they are. And the epigenetic pattern will correlate between the people of the same age very much. And the young people will have, again, the very same correlation, high correlation between them. And luckily, we see that while reprogramming happens, this epigenetic age, it uses the same trajectory, while in a reverse direction. It rewinds the epigenetic age of cells or organism, mice, in this case, when reprogramming happens. And so this is the basic idea. Let's take this reprogramming approach and just use part of it, and hopefully the biology will support the idea that this rejuvenation can happen on multiple levels many times, and will then prolong lifespan while you have a younger organism after this procedure for a long time, until it probably will revert back, the epigenetic will revert back to your original age, original biological age. But so the time that it will take, how long it will take before it recovers, is still to be discovered. Hopefully we'll just have to do the rejuvenation process, at such intervals, while we don't allow this epigenetic clock to get back to this high value, again, this old value, before we do the next round of rejuvenation.
It's very interesting.
I think this approach has a lot of potential. There are two companies now, one out of Stanford, one of Harvard, who are also working on it, translating it to clinic. One of the founders of this company, Vittorio Sebastiano, he will be speaking tomorrow. You should probably talk to him as well. The company is called Turn Biotechnology. And he's been writing about this approach since 2015, and we've been talking about it for a very long time. I'm a big fan of his work, and I think there's a very good chance that this approach will soon find its way into clinical trials and probably pets to us, and we'll see just how, if our optimism is warranted. Of course, it's still, we have to validate all these hypotheses, but I'm very optimistic, and I hope that in a very short period we'll have meaningful first rejuvenation, which is very easy to see. You can see if your dog is actually behaving younger, and then also life extension once we run the studies through the full course. So I'm very optimistic. Well, at this point, the experiment that we're doing is we're trying to see if just one of the 4 Yamanaka factors, so there's 4 OSKM, just one of the 4, OCT4, can be enough to cause the epigenetic rejuvenation without actually risking losing the differentiation of the cell. So basically we're trying to optimize the reprogramming approach to get something safer, because the problem with the Yamanaka factors is that cells actually lose differentiation, because originally Yamanaka developed his factors to actually cause cells to become pluripotent. We don't want that. We want just them to be rejuvenated enough, but not lose their differentiation, to remain the same cells that they are. So right now we're having this experiment in vitro to see if OCT4 can do this job safely. To describe in a short sentence what the startup is doing, so we're trying to develop gene therapy for epigenetic rejuvenation. So basically a therapy that will enable people to get younger in regular intervals. So in 100 years, I see myself on Mars, and hopefully doing some very cool things with space exploration. And interestingly, a lot of the people in the life extension movement are also avid space fans and space exploration fans and Mars fans. So I think there's a lot of cross breeding between people who actually want to go to Mars and people who want to extend lifespan. I love talking about these topics, and I'm sure you do. Everybody in this industry very, very much so. We're passionate about life extension and actually inspiring others to become passionate about it as well, because without it, there's just not enough political will in societies at large to invest large funding into scientific research, without which I think it'll take much longer to get these therapies.
Definitely.
I think it's just the mindset of people who are dreamers, and they want to they aspire to something more. We want to not just for themselves, but as humanity. We want humanity to do better than just to watch Netflix and do stupid, boring stuff. We want to do something interesting, something that we can write books about. You don't write books about, I just watched a TV show. You write books about exploring Mars, and we're going to Alpha Centauri and Kepler 186 and all the other things that are very interesting. And I think that's why a lot of people want to. They understand that the limiting factor is their death and their limited lifespan, and aging is what is holding us back from exploring these things that will take 100 years or maybe even 1,000 years to go to the stars. So I think a lot of people think about it from this perspective, why they want to live longer, because a lot of interesting things that can happen.